A systemic paralysis is quietly spreading through the high-performance corridors of the American automotive industry, one that global equity markets have almost entirely failed to price in. As the United States pours billions into the domestic production of electric vehicles, a singular microscopic point of failure has emerged, threatening to render the most advanced assembly lines on the planet inert. Public discourse frequently identifies lithium scarcity, cobalt ethics, or semiconductor shortages as the primary culprits behind projected manufacturing delays. These are false leads. The actual threat is far more fundamental, rooted in a metal that has underpinned global currency and commerce for millennia. This vulnerability is not a result of accidental scarcity, but of a calculated decade-long industrial encirclement. The architects of this crisis have realized that one does not need to own the world's mines to control its future. One only needs to own the bottleneck through which all efficiency must pass. In the sterile, high-precision environments of modern power electronics, silver is the silent guarantor of efficiency. As the most electrically conductive element on the periodic table, it is the fundamental medium through which the energy transition must flow. While the internal combustion engine functioned as a mechanical marvel of steel and heat, the electric vehicle is a complex electronic instrument. To achieve the energy density and range necessary for mass market viability, manufacturers have been forced to double their reliance on silver. An average internal combustion vehicle utilizes between 15 and 28 grams of the metal. A high-performance electric vehicle, such as those produced by Tesla, requires up to 50 grams. This silver is not concentrated in a single, easily replaceable component. It is diffused across the entire architecture of the vehicle, woven into the printed circuit boards of battery management systems, silver-plated connectors, high-voltage inverters, and the intricate sensor arrays that power autonomous driving. By 2024, Tesla's annual production surpassed 1.7 million units. When scaled across their entire fleet, this represents a consumption of approximately 2.8 million troy ounces of silver for a single corporation. On a global scale, the automotive sector now absorbs over 90 million ounces of silver annually, a figure projected to rise as the world's transportation fleet electrifies. However, this demand curve is colliding with a rigid, unresponsive supply reality. Approximately 72% of global silver is produced as a byproduct of lead, zinc, and copper mining. This means that silver supply does not respond to its own price signals. Even as the price per ounce escalates, production remains tethered to the demand for industrial base metals. This creates a structural inelasticity that leaves high-tech manufacturers uniquely vulnerable to supply shocks. The vulnerability is not merely a matter of geology, it is a product of strategic industrial positioning. While Mexico remains the world's leading producer of raw silver ore, accounting for roughly 24% of global output, the geopolitical center of gravity lies elsewhere. The critical stage of the supply chain, the smelting and refining process that transforms raw concentrate into the 99.9% pure silver required for industrial electronics, is dominated by the People's Republic of China. This dominance mirrors the strategy employed with rare earth elements. By subsidizing and scaling massive processing infrastructure, China has established a toll booth through which the world's mineral wealth must pass. Even silver mined in the Americas or Australia often traverses Chinese smelting facilities before it can be utilized in a Western factory. In April 2025, this structural dependency was officially weaponized. Beijing imposed a series of export controls on critical materials, citing national security concerns. While the initial focus was on heavy rare earth elements, such as dysprosium and terbium, essential for EV permanent magnet motors, the secondary effects rippled through the silver and base metal processing sectors. European and American supply chain managers suddenly faced a landscape of license denials, end-user audits, and indefinite administrative delays. Prices for processed materials in non-Chinese markets decoupled from global benchmarks, surging by factors of 3 to 6. The message delivered to the boardrooms of Austin, Detroit, and Wolfsburg was unambiguous. The physical components of the Green Revolution are subject to the strategic dictates of a rival power. Tesla's financial position has become the primary laboratory for observing this crisis. Throughout 2024 and 2025, the company engaged in a brutal price war to maintain market share against Chinese competitors, like BYD, which benefit from a fully integrated domestic supply chain. This strategy resulted in a precipitous collapse of profit margins. By the third quarter of 2025, Tesla's automotive gross margin, excluding regulatory credits, hovered between 14.7% and 15.4%, levels traditionally associated with legacy automakers rather than high-margin technology firms. With margins already compressed, the company has no buffer to absorb a spike in raw material costs. Tesla is caught in a pincer movement. They lack the pricing power to pass costs to consumers, and they lack the supply chain autonomy to avoid the escalating costs of processed metals. In late 2025, a temporary reprieve was reached. Following high-level negotiations in South Korea, China agreed to suspend many of its most restrictive export controls. To the casual observer, the crisis appeared to have been averted. Markets stabilized, and the immediate threat of production halts receded. However, the fine print of the agreement reveals a different reality. The suspension of these controls is not permanent. It is scheduled to expire in November 2026. This date now functions as a geopolitical expiry wall. It represents the deadline by which Western manufacturers must either find a way to replicate decades of Chinese industrial investment or face a return to the strangled supply conditions of early 2025. For the American electric vehicle industry, the clock is no longer ticking toward a production milestone, but toward a structural reckoning. Tesla's exposure to this geopolitical bottleneck is most acutely visible at its Shanghai Gigafactory, an 860,000 square meter facility that has become the undisputed engine of the company's global delivery network. By December 2025, the Shanghai plant achieved a milestone of 4 million cumulative vehicles produced, contributing nearly 50% of Tesla's total worldwide output. The facility's efficiency is unparalleled, with a completed vehicle rolling off the assembly line every 30 seconds. However, this operational brilliance is underpinned by a localized supply chain that is over 95% dependent on Chinese vendors. The architecture of dependency extends to the most critical component of the electric vehicle, the battery. Tesla excites the Texas-based production of the 4680 large format cylindrical cell, touted as a breakthrough in cost and energy density, relies heavily on Chinese expertise and materials. Since late 2023, Tesla has sourced cathode materials and precursors from Chinese suppliers such as Ningbo Ranbei New Energy and Suzhou Dongshan Precision. While Tesla has successfully mastered the dry cathode manufacturing process to reduce costs, it remains tethered to a network of roughly 400 Chinese suppliers for the integrated electrical systems that consume the bulk of the vehicle's silver content. In late 2025, the fragility of this arrangement was laid bare. On October 9, 2025, the Chinese Ministry of Commerce announced an unprecedented expansion of export controls. For the first time, silver was officially designated a tightly controlled export, placing it on the same strategic footing as rare earth elements and graphite. These measures require Chinese exporters to obtain specific government licenses for all outbound shipments of refined silver and silver-bearing compounds. By December 1, 2025, the mandate was further escalated to include internationally made products containing Chinese-sourced materials. This created an immediate administrative chokehold on any manufacturer using Chinese refined silver in Western factories, regardless of where the final assembly took place. The timing of these restrictions coincided with a period of extreme stress in the physical silver market. By the end of 2025, the global silver market entered its fifth consecutive year of structural deficit, with demand outstripping supply by approximately 95 million ounces. This cumulative shortfall, totaling nearly 820 million ounces since 2021, has systematically drained above-ground inventories in major trading hubs like London and New York. As industrial demand from solar, photovoltaics, and AI data centers surged, the available free float of silver plummeted, leading to a liquidity squeeze that drove prices to a historic milestone of 65 per ounce in mid-December 2025. For Tesla, the implications of a $65 silver price are mathematically punishing. With automotive gross margins already compressed to 14.4% by the fourth quarter of 2025 due to softening demand in Western markets and relentless competition from BYD, the company has lost the ability to absorb commodity price spikes. Unlike previous cycles, where Tesla could use its premium brand status to raise prices, the current environment is one of deflationary pressure in the EV sector. Every incremental dollar added to the cost of silver-plated connectors or battery management circuits directly erodes the bottom line, transforming the electric vehicle from a high-tech growth engine into a low-margin industrial commodity. This is the silver trap, a collision between an accelerating global demand for electrification and a supply chain that is geographically and strategically concentrated in the hands of a primary rival. The United States remains 100% net import reliant. For many of the critical minerals required to process this, silver and domestic refining capacity is insufficient to meet the projected demand of 80 million ounces for the automotive sector alone by 2026. While the South Korea Truce of late 2025 provided a temporary suspension of some export licenses, it did nothing to address the underlying structural deficit. The November 2026 expiration date of this truce now looms as a hard ceiling on Western industrial output. In October 2025, the strategic landscape shifted from theoretical risk to administrative reality. The Chinese Ministry of Commerce, MOFCOM, issued Announcement No. 68, a directive that fundamentally altered the flow of refined silver across the globe. Under this new regime, Beijing established a stringent licensing framework that filters the pool of eligible silver exporters, favoring a select group of large, state-integrated producers. This policy does not merely monitor exports, it acts as a valve, allowing the Chinese state to adjust the global supply of refined silver in accordance with its strategic priorities. The timing of this directive proved catastrophic for Western industrial planners. By late 2025, silver had transitioned from a traditional precious metal into a critical raw material, as designated by both the European Union and the United States. This reclassification was driven by a relentless physical deficit. Global silver inventories have faced 5 consecutive years of shortfall, resulting in a cumulative deficit of approximately 820 million ounces since 2021. In mid-December 2025, the physical market reached a breaking point, with silver prices surging to a historic milestone of $65 per ounce, a 120% increase within a single calendar year. For Tesla and the broader American EV sector, the $65 threshold represents more than a price spike. It is a margin-erasing event. Tesla's aggressive price cuts throughout 2024 and 2025 were predicated on the assumption of declining battery costs. While lithium prices softened due to temporary oversupply, the surge in silver and other minor metals like antimony and tungsten, also restricted under Announcement No. 68, has created a new, inflexible cost floor. With automotive gross margins already under severe pressure, the industry is unable to pass these costs to a consumer base already weary of high interest rates and economic uncertainty. The vulnerability is compounded by the 0.1% rule, a secondary directive issued by MOFCOM on October 9, 2025. This regulation asserts extraterritorial jurisdiction over any product manufactured outside of China if it contains Chinese origin rare earths or critical materials representing more than 0.1% of its total value. For the complex electrical architectures of modern EVs, staying below this threshold is a technical impossibility. The rule effectively gives Beijing the legal framework to intervene in the on-sale of Western-made vehicles to third countries, transforming a private commercial transaction into a matter of Chinese regulatory approval. In response, the United States has attempted to accelerate its de-risking strategy. The goal is a complete phase-out of Chinese-made components from American factories by 2027. However, industrial infrastructure cannot be willed into existence. While the U.S. has approximately 24 refineries capable of producing commercial-grade silver, they are largely optimized for recycling and secondary production. They lack the integrated smelting capacity to process the complex silver-bearing concentrates that China has spent decades monopolizing. The U.S. remains over 50% import-reliant for silver, and for many of the processing chemicals and specialized equipment needed to refine it, the dependency remains near 100%. As 2025 draws to a close, the South Korea Truce remains the only barrier preventing a total supply chain freeze. This temporary suspension of some export restrictions allowed a limited flow of materials to resume in late December, providing a veneer of stability to global markets. Yet this stability is an illusion. The truce is a tactical pause, not a resolution. It is set to expire in November 2026, creating a hard deadline for the Western automotive industry. The choice is stark: successfully decouple from the world's dominant refiner in under 12 months, or accept a future where the production volumes of the American electric dream are determined in Beijing. The institutional panic surrounding the silver trap is not merely a reaction to high prices, it is a response to the evaporation of physical liquidity. By December 2025, the global silver market had entered a state of backwardation, a rare market condition where the immediate spot price of the metal exceeds the price of future delivery contracts. In London and New York, the two primary hubs for physical silver trading, registered vault stocks have plummeted to their lowest levels in over a decade. This is the hallmark of a market where industrial users, desperate to keep assembly lines moving, are bypassing traditional paper exchanges to secure physical metal at any premium. This liquidity crisis is the direct result of a fundamental miscalculation in Western industrial policy. The United States Inflation Reduction Act, IRA, and similar European mandates were designed to subsidize the demand for green technology without securing the upstream mineral processing required to build it. While the U.S. Geological Survey, USGS, officially added silver to its critical minerals list in early 2025, the move was a trailing indicator of a crisis already in motion. Domestic mine production in the United States, centered in Nevada and Idaho, yields approximately 35 million ounces annually. This output is a fraction of the 95 million ounces the U.S. automotive sector alone is projected to consume by 2026. The structural rigidity of silver supply exacerbates this deficit. Because 75% of silver is a byproduct of mining for lead, zinc, and copper, even a $65 or $70 silver price is insufficient to trigger a significant supply response. A copper miner in Peru or a lead producer in Australia will not increase their total mine throughput simply because the impurities in their ore, the silver, have surged in value. To bridge the gap, the industry relies on thrifting, the technical process of reducing the amount of silver used per component. However, in the high voltage environment of an EV, thrifting has reached its physical limit. Reducing silver content in power inverters increases electrical resistance, leading to heat buildup, reduced range, and potential component failure. For manufacturers like Tesla, the choice is between paying record premiums for silver or sacrificing the very performance metrics that define their brand. The geopolitical dimension of this shortage became undeniable on December 14, 2025, when reports emerged that major Chinese state trading enterprises had begun stockpiling refined silver, further tightening the export licensing regime under Announcement No. 68. This strategic hoarding suggests that Beijing is preparing for a protracted period of trade volatility. By restricting the outflow of refined metal while maintaining its dominance in base metal smelting, China has effectively exported its own supply chain security at the expense of the rest of the world. The South Korea Truce is increasingly viewed by analysts as a strategic feint designed to prevent a total Western pivot toward alternative processing technologies until it is too late to meet the 2026 deadlines. For the American EV sector, the financial consequences are already appearing in the form of shadow inflation. While headline inflation figures may appear stable, the internal cost of goods sold, COGS for electronics-heavy industries, is diverging sharply. Tesla's operating margin, which fell to 5.8% in late 2025, reflects the reality that the company is now a price taker in a market controlled by its primary geopolitical rival. The de-risking deadline of 2027, the year Tesla aims to eliminate Chinese components from its U.S. supply chain, now feels like a distant horizon. Between today and that goal lies the November 2026 expiry wall, a date that may mark the end of the temporary truce and the beginning of a true industrial siege. The resolution of the silver crisis requires more than just capital. It requires a fundamental restructuring of the Western industrial model. As 2026 approaches, the global silver market remains trapped in a structural deficit that no amount of financial engineering can resolve. The 95 million ounce shortfall projected for this year is a physical reality that transcends stock market valuations or corporate rhetoric. For Tesla and its peers, the period of unlimited growth is colliding with the hard limits of the periodic table. Industrial history suggests that when a critical material becomes a geopolitical weapon, the affected industry either adapts or undergoes a painful consolidation. In the 1970s, it was oil. In the 2010s, it was semiconductors. Today, it is the refined metals that power the electronic nervous system of the modern world. The silver trap is the first major stress test of the global energy transition, proving that a green future is not a resource-free future. On the contrary, it is more mineral-intensive and more dependent on concentrated supply chains than the fossil fuel era it seeks to replace. Tesla's management remains committed to the 2027 de-risking deadline, but the interim period represents a valley of death for the American EV sector. To survive until domestic refining capacity can be scaled, manufacturers are being forced to explore radical alternatives. Research into copper-graphene hybrids and synthetic conductive polymers has accelerated, but these technologies remain in the laboratory phase, years away from the high-volume reliability required for automotive standards. In the immediate term, the only viable strategy is the aggressive stockpiling of physical metal, a move that further tightens the market and drives prices higher, feeding the very crisis it seeks to mitigate. The November 2026 expiry wall is not just a date on a trade agreement, it is the moment when the South Korea Truce expires, and the full weight of Chinese export controls could return. If Beijing decides that its strategic interests are better served by withholding refined silver than by selling it, the American EV industry faces a hard production ceiling. Factories that cost billions to build could sit idle, not for a lack of demand or a lack of labor, but for a lack of 50 grams of silver per vehicle. This is the reality of the new mineral mercantilism. For the investor, the lesson is one of structural awareness. The era of evaluating EV companies based solely on software, autonomous driving dreams, or quarterly delivery targets is over. In the new macro environment, a company's value is dictated by the security of its upstream supply chain. Those who control the processing bottlenecks control the pace of the global economy. As the silver deficit widens and the geopolitical clock ticks toward November 2026, the industry is moving from a battle for market share to a battle for survival. The silver trap has been set. The only question remaining is who has the industrial agility to escape it?